Like clockwork, a baffling sign punctures the quiet of the universe. Stargazers are confounded because they've been hearing this sign for an astonishing 35 years, and as of recently, its true origin has been a mystery. This sign could be a totally new cosmic phenomenon, or it may be a message whose calculation and genuine importance we have not yet perceived. Where does this strange signal truly come from? Why is it so unique in relation to any remaining sounds and signals in space? Have researchers finally tracked down a possible solution? Signals in space are quite strange, but this sign, which we've been receiving with astounding regularity for decades, is unlike any other sound in the universe. While most grandiose signals tend to be irregular or short-lived, this sign has proven to be surprisingly stable and consistent over a remarkably significant stretch of time. Cosmic signals can originate from a whole range of cosmic phenomena, including stars, galaxies, quasars, and neutron stars. Pulsars are a class of particularly fast-rotating neutron stars that emit high-energy radiation. These beams travel through space like beacon signals and sound a bit like the traditional ticking of a clock. Precision signals from quasars or active galactic nuclei are more like noise, sometimes having sharp peaks or sometimes stretched, depending on whether they originate from slower, large-scale processes in the universe. The last phenomena in this series of well-known and well-studied grand transmissions are the fast radio bursts, FRBs. These short and very intense signals last only microseconds. Their origin has not yet been completely explained, but they likely also start from enormous radiation sources, such as quasars or gamma-ray bursts. FRBs typically sound once or with a few repetitions, resembling sudden, bright shouts in the cosmic silence that quickly fall silent again. The signal that has caught the attention of specialists for so long doesn't fit into any of these classifications. Like an eager cosmic metronome, it conveys a mysterious message. Like clockwork, each signal comprises individual heartbeats lasting between 30 seconds and 5 minutes. These heartbeats consistently occur at intervals of 21 minutes and 58 seconds and last around 6.5 minutes. Despite the variation of the individual heartbeats, this source shows amazing reliability due to the specific spans between the individual signs and the progression over 35 years. While the frequency would be consistent with a pulsar, the unusual length of the beats among signals and the consistency of the pattern over many years contradict the behavior of a normal pulsar, whose flags typically occur at much shorter, more regular intervals and at a higher frequency. Is it a message we don't comprehend? Scientists were amazed when they heard this signal for the first time in 1988. It was clearly different from the regular tumultuous noise of space and caused a minor sensation. Given such consistency, researchers quickly searched for all suitable explanations. However, in the case of the signal, which has been given the name GPM J111839-1842, there was no confirmation of first contact with extraterrestrial life, and researchers found it hard to decipher the signal. Radio transmissions usually sound like specific irregular or intermittent patterns, and this was certainly evident with this signal. However, all the unraveling techniques known on Earth couldn't extract any deeper significance from the signal. Clearly, we can never rule out the possibility that different species use totally unique frequencies and calculations to convey informative messages into space and that we simply fail to decode such messages. It is also noteworthy that our own messages, which we send into space via radio waves, have never been replied to. Measurements have indicated that there could be around 30 intelligent civilizations in the Milky Way alone. GPM J11183910. Who is conveying the message? Have you ever pondered who might respond if we send messages bundled as good tidings randomly into the universe? The first signal of this type was sent from the Arecibo Observatory in 1974, following the initial efforts to make contact with extraterrestrials via radio signals, which formed into the Search for Extraterrestrial Intelligence, SETI. This scientific association has set itself the goal of using radio astronomy to look for indications of intelligent life outside of Earth. To this end, SETI researchers primarily listen for electromagnetic signals that may have been emitted by extraterrestrial civilizations. Since the 1960s, researchers have developed various strategies and advancements to sift through potential messages or signals from extraterrestrial intelligence from the tremendous noise of the universe. Specialists call such calculations technomarks, which typically vary significantly from regular signs due to repetition rates and a certain complexity of frequencies. Some critics believe that this quest for extraterrestrial signals is akin to searching for a needle in a haystack, given the vast size of the universe. Considering the dimensions and the distances between star systems and the millions of stars in the Milky Way alone, it may indeed seem daunting to find open ears or receive other signals. Here, the fact that we can capture signals from massive events thousands of light years away gives us hope. Yet, critics make another argument: we can never know who is receiving these messages we send aimlessly into space. We cannot expect that all beings in the universe, if they exist, are friendly. That sounds terrifying, but it is true. Now we need to consider for a moment whether it is a pity that SETI has not yet identified a single signal that is clearly of artificial origin or whether it is a blessing. In all that time, around 5 signals have been hot contenders for first contact, and GPM J111839-1842 could be one of these exceptions. However, in almost all cases, natural explanations for the signals have been found. Is a divine body radiating the strange flags? Well, the mystery of the GPM J111839-1842 signal remains perplexing. It has been demonstrated that most signals traveling over significant distances in space are produced by magnetars, pulsars, or neutron stars when Australian scientists found an exceptionally specific magneta, located around 15,000 light-years from Earth, was discovered in 2022. At first, researchers were bewildered by this neutron star, which is now turning gradually. This behavior suggests that it is extremely old or represents some other peculiarity. Normally, a magnetar spins at rates of several turns each second. However, this particular object has extended its rotation period to an astonishing 22 minutes. It is not yet known why this magnetar has changed its behavior in this manner. It could be an indication of age, but typically, old magnetars with such slow spin rates no longer emit signals. Scientists are aware of a threshold for the spin rate below which a neutron star loses its radiation and its ability to send pulsating signals into space. Nevertheless, this neutron star rotates slowly and continues to transmit messages into space remarkably often. It was discovered by a team of researchers from Centre College, utilizing the Merchandise and Wide Field Array in Western Australia. Researchers typically find objects like this by analyzing electromagnetic waves. Magnetars and pulsars must be identified in the vastness of the universe by their radiation and acoustic signals, as they no longer emit visible light when they become inactive. Radio astronomers specialize in such objects. They study phenomena such as pulsars or fast radio bursts with large radio telescopes. Facilities like the Arecibo Observatory in Puerto Rico and the 500-meter spherical telescope in China utilize massive dishes to capture radio waves rather than optical signals. The FAST telescope, often playfully referred to as China's Sky Eye, has an impressive diameter of 500 meters and is the largest radio telescope that receives countless signals from space around the clock with a single dish. Today, radio astronomers no longer listen to space with their own ears, as most signals from space are not even audible to human ears. Advanced computers filter the signals, check specific sound tracks, compare them with known data, and report all significant or unexplained signals. This is how the Australian researchers detected the signal that repeated approximately every 22 minutes. They suspect it is a magnetar that has been sending signals for an extended period. In their publication in the scientific journal Science, the researchers from Australia connect the newly discovered signal with a much older phenomenon. The article reports on a puzzling signal that was first received in the late 1980s and was never fully decoded. The scientists are confident that this signal and the magnetar they found are the same. The magnetar was situated in the constellation Scutum, very close to the more well-known constellation Sagittarius. In their study, the researchers examined the repetition rates of neutron stars, which typically emit signals within a span of minutes or even seconds. The long intervals at which GPM J1839-10 emits signals are shown to be peculiar. Another similar signal was observed about 18 months before the discovery of the magnetar in scutum. The same research team had already found a celestial body that radiates signals like clockwork. This phenomenon could therefore occur more frequently than previously expected. The radio emissions in neutron stars result from the rotation of the celestial body and its magnetic field. Magnetars are a special type of neutron star equipped with an exceptionally strong magnetic field, approximately 2 quadrillion times stronger than Earth's magnetic field and 20 trillion times stronger than the magnetic field that holds a standard paperclip. These magnetic giants emit impossibly high spectra of X-rays and gamma rays, often accompanied by significant cosmic flares on their surfaces. Magnetars can produce energy equivalent to the intense primordial force that formed our planet in its earliest stages. Neutron stars are formed when a star explodes in a supernova. The remnants may either become a black hole, a conventional neutron star, or an exotic type of pulsar or magnetar. Typically, magnetars are active for only a few years, so the fact that such an object has been emitting detectable signals at an active rotation rate for over 35 years is exceptionally rare. Researchers now want to study this mysterious object in more detail and hope to gain deeper insights into the nature of neutron stars. The object has been temporarily classified as an ultra-long-period magnetar until further characterization of the phenomenon can be completed. Signals from 9 billion light-years away are being monitored, with scientists around the world tuning into space using massive radio telescopes. Practically no sound escapes the analysts, rather, nothing gets past the computers that monitor the observations. It is hardly feasible for the human ear to recognize and filter all the signals and noise from the universe. This is accomplished by finely tuned programs. Generally, received signals undergo smart filtering and analysis. Non-stop, whether lightning commotion signals or waves, the calculations perceive all known frequencies, their adjustments, deviations, and varieties. Then, if a recurrence or sign is recorded that the PC users don't perceive, a caution goes off promptly. Then, the information is surveyed by researchers. Overall, there are many of these cautions consistently, yet the vast majority of them are mistakes, signals from peculiarities that are very simple to make sense of, all things considered, or, on the other hand, flags from sources of impedance on the planet or from satellites. Something like 12 signs each year start from beforehand obscure corners of the universe or from incomprehensible events. Worldwide, groups of researchers are managing these obvious radio transmissions. They attempt to decipher and translate the frequencies. Considerably more uncommon are signals that contain alleged technosignatures. Technosignatures are frequencies and waves that are drawn in such a way that regular peculiarities can be precluded as sources. The most far-off signal of all time, estimated, was as of late gotten by 2 analysts from Canada and India. Astronomer Denai Kadi of Canada's McGill University and his associate Anam Roy of the Indian Institute of Science were able to catch an interesting radio transmission. The analysts accomplished this with the help of the Giant Meter Wave Telescope in India, the world's largest radio telescope for frequencies in the meter range. It is situated around 80 kilometers from the Indian city of Pune, at a height of 588 m. Starting investigations of the sign have currently revealed that it begins from a universe something like 8.8 billion light-years away. This makes this sign totally unique. Up to this point, the discovery was only possible on account of the gravitational lensing effect, which we also know from the perceptions of optical reflecting telescopes. The gravitational impact of enormous objects causes specific regions in the universe to become more conspicuous, allowing older objects behind the scenes to become apparent, or, in this case, perceptible. The sign, approximately 9 billion light-years away, was bent by the presence of another huge system between the target and the eyewitness, which actually amplified the signal by a factor of 30. So, what works with light waves and optical impressions also works with radio waves. Canadian astronomer Kadi explained that until now, this kind of radio transmission could only be gotten from universes closer to Earth. If specialists can now utilize the gravitational lensing effect with radio waves, It means we'll soon be able to listen farther and deeper into space, and in this manner, into the past. Of course, radio waves also take a long time to contact us, so a sign that has traveled 8.8 billion light-years comes from a far-off past. The system SDSS J0826 plus 5630, from which the sign begins, previously existed when the universe was still very young. Regardless of whether specialists consider it up to this point, it's unimaginable that as of now, highly developed living creatures existed in the universe. Naturally, the question emerged whether the sign from system SDSS J0826 plus 5630 is of regular origin or whether it concerns a technosignature. The quest for signals from other life structures yields very few inestimable signs, aside from the background noise of the universe and signs beginning from our immediate vicinity that traverse long distances. Most sounds or radio waves get lost in the immeasurability of space or in the vacuum of interstellar space.